Here we have a SAT math problem. Okay, let's go to the question. We have two functions over here. There is f of x equals to x square negative 6x positive 12 and other function is g of x equals to k. In the equations above, f of x is greater than or equal to g of x for all real numbers x. If k is a constant, what is the value of k? Okay, here we have a quadratic function. We know that the graph of a quadratic function will be a parabola, and here the leading coefficient, that is the coefficient of x square, is 1. It's a positive value. Then we'll be getting a parabola which opens up for this function, and this is linear function. I will be getting a line as graph for this function. Okay, when we have functions like this f of x and g of x, on an xy plane, when we sketch the graph of these functions, this f of x and g of x will represent the y coordinate. So we can replace this f of x and g of x by y. Then we get y equals to x square negative 6x positive 12. And for this one, we get y equals to k. Okay, according to this information, the value of y we have in the quadratic function always has to be equal to the value of y in the linear function, or the value of y in the quadratic function has to be greater. Okay, now what we can do is we can sketch the graph of this quadratic function, that is a parabola which opens up. For that, we need the vertex of the parabola. So to get the vertex of the parabola, there is a formula to get x coordinate of the vertex. It is x equals to negative b over 2a. Okay, here we can take this negative sign as it is, and this b is the coefficient of x. The coefficient of x over here is negative 6 over 2 times. Here a is the coefficient of x square. In this case, it's 1. That is 2 times 1. Then we get x equals to negative times negative is positive. That is 6 divided by 2 times 1 is 2. So when I simplify this, I am getting 3. Okay, I got the x coordinate of the vertex of the parabola. To get the y coordinate, what I have to do is I have to plug in this 3 for x into the quadratic function we have over here. Then I'm getting y equals to 3 square, negative 6 times 3, positive 12. Okay, now let's simplify this one. The value of 3 square is 9. Negative 6 times 3 is 18, positive 12. Okay, when I combine this positive 9 and positive 12, I'm getting positive 21. Then when we combine positive 21 and negative 18, I'm getting 3. Okay, I got the y coordinate of the vertex of the parabola, that is 3. Already we have the x coordinate, that is 3. Therefore, the vertex of the parabola is 3, 3. Okay, now we can sketch the graph of the parabola on xy plane. Okay, let me do it. Here we have the xy plane. Okay, let me plot this vertex 3, 3. That is x coordinate 3 and y coordinate 3. Then we'll have the vertex over here 3, 3. Okay, here the leading coefficient of this quadratic function is positive. That is 1 way over here. Since the leading coefficient is positive, the parabola we get for this quadratic function must open up. Okay, let me draw a parabola which opens up. Okay, let me draw it. Okay, now we have to sketch the graph of this linear function g of x equals to k or y equals to k. Actually, it has to be an horizontal line through the value k on the y-axis. Okay, what must be the value of k? That's what we have to find. Okay, now let me draw an horizontal line through the value 3 on the y-axis. When I do so, here this horizontal line is tangent to the parabola exactly at the vertex we have over here. Okay, how can I decide that this horizontal line must be passing through the value 3 on y-axis? Because there is a condition given over here. That is, the y coordinate of the parabola can be equal to the y coordinate of the line, or the y coordinate of the parabola has to be greater than the y coordinate of the line. So only if I draw the horizontal line through the value 3 on y-axis, and also it is tangent to the parabola vertex. So the y coordinate of the parabola and y coordinate of the line can be equal. So here at this vertex, so the y coordinate of the parabola is 3, and also the y coordinate of this line over here is 3. Both of them are equal. If I consider any other point on the parabola, for example, let me consider a point over here. What is the y coordinate at this point? That is 4. So at this particular point, the y coordinate of the parabola is greater than the y coordinate of the line, 3. Okay, if I consider any point on the parabola other than vertex, the y coordinate will be greater than the y coordinate of the line. Because on this line, on this horizontal line, if I consider any point, the y coordinate will be 3. Because for example, let me consider a point over here. What's the point over here? It's 1, 3. If I consider a point over here, that is 2, 3. At any point, the y coordinate will be 3 on this horizontal line. So the horizontal line, I mean this y equals to k, must be drawn through the value 3 on the y-axis so that the y-coordinate of the parabola can be equal to the y-coordinate of the line, or the y-coordinate of the parabola will be greater than the y-coordinate of the line. Okay, so since this horizontal line is passing through the value 3 on y-axis, the equation of the line can be written as y equals to 3. But already we have the equation of the line y equals to k. So this y equals to k and this y equals to 3 represent the same stuff. So when we compare this one and this one, at the place of k we have 3. Therefore, the value of k is 3.